Hi, welcome to this video on sequence and data. I'm Andrew. So far we've been looking at how the computer works and some command line tools that we can use to get it to do things. We've seen how we can use those to build and run programs. We're now getting ready to explore creating our own programs. So what's programming all about? Well, learning to program is all about getting the computer to do the things that you want it to do. At the very start of this journey, we want you to focus on the basics. So the field guide is going to build you up from the bottom up. The idea of this is that you can focus on these core mechanics, these really simple things that are the foundation of all of the things that happen within the computer. Having a really good understanding of each of these things and how they work will really help you make sense of everything that happens as you go forward. So having a really strong foundation is important. The most fundamental thing that we can look at is the idea of sequence. The fact that a program is a sequence of instructions that gets the computer to do something. In this part of the book, part 1, we're looking at programs as instructions. And so here in this chapter, we're looking at how those instructions are a sequence, and you can use data within that sequence to do some interesting things. We're going to look at the idea of instructions and sequence. We'll look at methods and method calls, and then we'll look at variables and the assignment statement. Let's get going. Instructions and sequence are really the core foundation of programming. And the idea that one line of code might actually be a few different instructions that are doing different things, but always in the same sequence. Realizing that, this really simple thing is underpinning all of your programs is really important. So let's have a look at this idea quickly. When we run a program, I execute my Hello World program, what happens is that program's code is loaded into memory. Now that's not the source code that we write, but the machine code that the computer can execute. So these are the binary instructions that the CPU utilizes to perform different functionality. When the program starts, we have what's called a program counter inside the CPU. And that program counter will store the address of the instruction that's going to be executed. So when the program starts, it will load up the first instruction of that program, and that will be what is going to execute when the program starts. So how does execution work? Well, each of the instructions is read out of memory into the CPU, and that instruction triggers the different mechanisms within the CPU for it to do whatever that instruction is designed to do. Pretty simple, yeah? Once it's finished that instruction, what does it do? Well, it adds 1 to the program counter. So the program counter, which was 1, is now incremented to 2. Gosh, really simple, yeah? What does that mean? That means now we are referring to the second instruction in the list of instructions that is the program. The computer continues to execute, so that will mean this instruction is read into the CPU. Whatever that instruction is occurs, so the mechanics of that instruction execute, and you'll never guess, at the end of that instruction, we add 1 to the program counter and it goes to the next instruction. And this process happens again and again and again, millions and millions of times every second. So we run through those instructions super fast. The way you can think of this is like a stream or a flow of instructions going through the CPU in sequence. So here we've got a picture that shows, these instructions in order, and we can see that instruction 18 was run first, and then 19, and then 20, and those instructions flow through the computer. Each instruction getting the computer to do the things that instruction requires of the computer. And this is all achieved through this program counter. And as we go through looking at programs as instructions, we'll need to think a little bit about how these instructions work and the mechanics of each of those instructions, or the mechanics of each of the bits of code that we write, and then they will have internally, or they will result in a number of instructions for the computer. All right, with such really small and simple things, how do we get anything meaningful to happen? Well, the main way that we do this is by grouping instructions together and packaging them up in things that we can use. And in C#, what we're going to be looking at here are the idea of methods, which are these packages of instructions, and then the idea of calling those methods to get them to do things. A method is quite simply just a package of instructions that we can call in our code. Each method would have a name, and that name is an identifier. That basically means it's a sequence of characters that uniquely identifies that method. So that when we say, I want to call the WriteLine method, the compiler is able to work out which method we actually mean, the one with the name WriteLine. Inside of the method, there'll be a number of instructions where it will get the computer to do the instructions needed to write a line on the terminal, for example, and then it has the ability to have some data that gets passed into it, which we'll look at in a second. So the idea is a method is just a bundle of instructions that we can call when we want those instructions to be performed. The method call is then a statement that we can use inside our code. And the method call will look something a bit like this, where we would have the name of the method, so the identifier at the start, and then in parentheses, in brackets, we would have all of the different values that we need to pass into the method. When we do this, the computer will jump to the instructions inside that method, and it would start executing those instructions one by one. When you get to the end of the method, it returns back to where you called it and goes to the next instruction that you've coded. Let's have a look at an example. So here is an example of some code out of the field guide. So we have an instruction at the top here that is giving us access to a library, and then we have 1, 2, 3, 4 statements here, 4 instructions. These statements are method calls. So open window here is going to open a window. It will have a random color, and we can pass in some values here, 800 and 600. We would have to know what open window needs. This is actually going to be the title of the window. That's going to be the width of the window, and that's going to be the height of the window. Then the next, when that finishes, so what's going to happen here, we get to there, it goes into the open window code, runs all that code, comes back, then goes to our next instruction. So now it runs clear screen. And here, notice we're actually calling another method here. So this is the idea that methods can give you back data as well. So the random color method will have a sequence of instructions, and at the end of those instructions, it's going to give me back some data, which is a color. So that might give me the color green, for example. And then the color green is going to be given to clear screen. So clear screen is then called. When that finishes, we go to the next line of code. And so we refresh the screen so the user can see it, and then we call delay. And here we have another example where we're calling another method. So we're calling RND10, that generates a random number between 0 and 9, so 10 random values, and we multiply that by 1,000. So that will give us between 0 and 10 seconds that the delay will occur. All right, let's have a look at that running. So we can run the program, and when we run it, it runs through those instructions. So it opened a window and generated a random color. If I run it again, we can see we get a different color, and each time we run it, we would get a different color and a different delay period. So that's the idea. We run through the instructions one at a time to generate the outcome we need. In addition to instructions, which are coded up inside methods, we can create variables to capture values that we want to change as the program executes. A variable can be thought of as a placeholder, a storage location inside which we can store a value. Each variable would have a name, and that name is an identifier used to indicate which variable we're talking about. We can use the assignment statement to store a value into the variable, and we can use expressions to read values out of the variable. Each variable would have a type as well, so it either stores a number, so an int or a double, or it can store text like a string. The assignment statement is then the statement that we can use to store a value in a variable. Now, in terms of our instructions, this performs sort of 2 steps. The first step is to evaluate the expression on the right-hand side. So here it would have to evaluate this, so 7 times 10, 70 plus 3, 73, and then the value 73 gets stored into the variable. So 73 would then be stored into that variable. So always important to remember, there are 2 steps to the assignment. Read the value on the right-hand side, or evaluate the expression on the right-hand side, and store it in the variable on the left-hand side. So here's an example of that. We've got a variable that we're declaring up here, name, and down here we are storing a value in name. So it's going to first execute this, the right-hand side, and call readline, and then it will store the result that we get from that into the name variable. So if we step through this code, what we can picture using tracing ideas here, where we hand execute this, like this creates some variable somewhere to store a value, and this variable here is called name. We write out the message, and then we read the line in. So if I type Fred, then Fred, writing with this mouse is not fun. We would have Fred, and Fred would be stored inside that variable. And so now when I read the value of Fred read the value of name in a later instruction, it would grab the value out of that variable. And if I ran it again and typed in something different, then the value in this variable would be that new value, or the value that I typed in. When we run the program, there we go, I can type in my name. That will be stored in the variable. So when it prints it out down on line 17, we get the name Andrew printing out. If I type Charlotte in, then that was the value stored in the variable, and we get hello Charlotte printing out. Are you ready to explore sequence and data? As you get started learning to program, focusing on these core mechanics will help you understand how things work and will help set you up for the future steps in this journey. So see how sequence is the foundation of all of the instructions that we're going to look at as we go forward. Things run in sequence, top to bottom in our code. And see how you can work with data using variables and expressions. There's lots of details in the text that will really help you come to grips with these different concepts and how to use them. As you work through this chapter, try to actively engage with each of the concepts. Write some small programs, test them out, get a solid understanding of these ideas in your head. It shouldn't be too challenging at this point. These ideas are fairly simple, but practice and really make sure you can see what's happening with the code. Enjoy the journey.